Hello everybody. In this video, we are going to discuss how to name saturated compounds or alkanes. So we already know how to write the parent names. That is on the basis of the number of carbon atoms. So if you have one carbon atom, we write meth, 2 is eth, 3 carbon atoms become prop, 4 is bute, 5 carbon atoms pent, 6 hex, 7 hept, 8 carbon atoms is oct, 9 is non, and 10 is dec. And then we add the suffix to it, which for alkanes is ane. So we already saw how this works in action. So 1 carbon CH4 becomes methane, C2H6 becomes ethane, and so on. So straight chain alkanes are just named by combining the prefix, which denotes the number of carbon atoms, and a suffix which denotes the kind of compound it is. For example, in alkanes, it is a single bonded compound. Now, let us go into naming these hydrocarbons. First, we have straight chains, and those names we already know. We just have to take the straight chain, count the number of carbon atoms, and then give the accorded prefix and suffix to it. In this video, we will be focused more on branched chain as to how to name these carbon atoms. And for doing that, we will rely on the IUPAC system of chemical nomenclature. So this system has laid out a set of rules, and these rules are followed universally to name any organic compound. So before we go and talk about naming these compounds, let us look at how I go about representing these compounds. So first way of representing is by the expanded structural formula. So in this kind of formulas, all the bonds in the atoms are shown. These are also referred to as Lewis structures. So this is an expanded formula for ethane. So you have 2 carbon atoms bonded by single covalent bond, and then 6 hydrogen atoms again bonded single covalently to the carbon atoms in question. So the next way of writing this is by condensed structure formula. And in the condensed formula, only specific bonds are shown. So the same ethane molecule can be written like this, where only CC single covalent bond is shown and all the hydrogen are condensed and written together. Next way of writing it is with the skeletal formula or the line drawing. In line drawings, bonds are simply shown by lines. So the end points of each line segment or any points of intersection would be considered as carbon atoms. So ethane is just represented like this using a line segment and the skeletal formula. So this line segment has 2 ends, and these 2 ends represent 2 carbon atoms. And the straight line in between is the bond. The hydrogens mapped to the carbon atoms are not shown in skeletal formula. But if the hydrogens are mapped to any other atom, we have to show them here. Now coming to IUPAC nomenclature. There are essentially 4 steps involved in naming a particular compound. So let's understand step 1. Step 1 is to identify the root or the parent. This simply is the longest continuous chain of carbon atoms. That chain is considered to be the parent chain. Step 2 is to identify the suffix. This identifies the main functional groups. In this case, all are single covalent bonds, and we talk about the suffix ane. Moving on to step 3. Step 3 is to identify the prefix. So a set of prefixes identifies the numbers and the positions of all the substituents attached. Now, substituents are any groups which are attached to the parent chain or the longest chain, and we will see what they mean with examples in a moment. And then moving on to step 4, we write the final name, and the name is, first we write the prefixes, then we write the parent root, and then we write the suffix. So before we go on to talk about writing the actual names, let's discuss what kind of groups can be attached to the parent chain. The kinds of groups that are attached are called alkyl groups. Now, how are these formed? Alkyls are simply formed when you take away one hydrogen from the corresponding alkane. So for methane, for example, CH4, we take away one hydrogen and then you are left with CH3 and a bond. This bond is the empty space for any other group to come and attach with it. So from methane, we get methyl group. Similarly, from ethane, removing one hydrogen, we get ethyl group, that is C2H5. From propane, we get propyl, butyl, and so on. So the general formula here is very simple. It is, we are removing just one hydrogen from the alkane. So the formula becomes CnH2n plus 1. Now, coming on to our main topic, the nomenclature. So the first step is to identify and name the longest continuous chain of carbons. So here I have a set of examples in which I have only denoted the carbons. The hydrogens are not denoted here for the ease of reference. So let us first find out how these carbons form the longest chain. So for the first example here, you will notice that there are 5 carbons. So this itself is the longest chain. So if you number it from this side or from the opposite side, makes no difference. Ultimately, it is a set of 5 carbons, and that itself is the longest parent chain. Let's look at this one, the second example. So here we have 1, 2, 3, 4, 5. This can be the first chain, or 1, 2, 3, 4 can be the second chain, or more appropriately, we can go 1, 2, 3, 4, 5, 6 as one chain, or 1, 2, 3, 4, 5, 6, 7, 8 as one continuous chain. So regardless of how they are branched, we need to find one continuous long chain, and for this case, it is a chain of 8 carbon atoms. So if I were to write the same here, this is how it would look like. So you have 8 carbon atoms, and on the 4th carbon, we have 1 carbon attached to it. So these two are essentially the same compounds. Now, looking at this, we know that this is the longest chain, and this is a group that is attached to it. So the longest chain is called the parent chain, and any group attached to the parent chain is called a substituent. Now let's move on to this example and find the longest chain. If you notice here, then these chains are in a continuous form. So this itself is the longest chain, and there are no substituents attached to it. Moving on to this example. So here if you see, it is 1, 2, 3. And then you have 1, 2, 3, 4, 5, 6, 7, 8 or 7, 8, 9. So essentially, we will take the longest chain to have the maximum carbon atoms. So this is a chain for 9 carbon atoms, where you have substituents attached at the 2nd position and the 7th position. Now, why did I not number it this way, where you have 1, 2, 3 and so on? This we will find out in the next rule. So here we move on to step 2. We number the atoms consecutively from end to end, so that the substituent gets the lowest possible number. So in this case, there are no substituents, so that's okay. For this case, however, we have to go from this end. because if we were to go from this end of the carbon chain, this would have been 1, 2, 3, 4 and 5. So the substituent would have gotten a larger number compared to when we number it from this end. We go to the numbering which has the lowest number that is assigned to the substituent carbon. So we go this way. Similar is the case on why we did that here. We have 1, 2, 3, 4 and that is the carbon attached. In this chain there is essentially no substituent, so let's skip that. And now again for this chain, we have numbered it this way. If we were to number it from this side, it would have been 1, 2, 3 for the substituent, 4, 5, 6, 7, 8. 8 for the substituent. So 3 and 8 is definitely greater than 2 and 7. And we choose the lowest numbers possible, so we choose numbering from this side. Now to go ahead and write the actual structures and the names, since we have already understood how we find out the parent chains and how we number them. The third step is to name the alkyl group which is present, which is again just the number of carbon atoms with the "-il" attached to it as suffix. So we will name this alkyl group and put the corresponding number of the carbon to which it is attached to. Let's look at some examples. So here I have the condensed formula of 5 different compounds, and we will try finding the substituents attached to these. So before we find the substituents, it is essential that we find the parent chain. So in this example, if it is 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. So 5 is the longest chain possible. So I will choose the straight chain for my convenience. And now second step is to number it. So numbering will start from this end because the substituent will get the lowest possible number 2. From this end, it would have gotten the number 4. So that's not acceptable. So we go numbering from this end. Now here is our substituent. We have to name this substituent. So this alkyl group contains only one carbon atom. So it's a meth group, and this particularly is methyl. And it is attached to the second position. So we write 2-methyl. Notice that the numbers and the letters are separated by a dash. Moving on to the second one. This is the parent chain. You can stop the video and count if you need to. And then this again is a chain of 5 carbon atoms. And we notice there are 3 substituents. 1, 2 and 3. So now let's go around numbering it. We could start from here, 1, 2, 3, 4, 5. So it would have been 2 and 4. And from this end also it would be 1, 2, 3, 4, 5. So this was also 2 and 4. So makes no difference from where you number it. So I will number it from this end. And to now write the name of the substituent and the attached numbers. So this would be 2-methyl, 4-methyl and another 4-methyl. Moving on to the third example. Now we would assume that maybe this is the longest chain. Let's find out. So it is 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5 and 6. So we see that 6 is the longest chain possible. Now to number. If you were to number it from this end, it would have been 1, 2, 3, 4 and 5. So 3 and 5 would have been the counts for the substituents. From this end, it is 1, 2, 3 and 4. So it is 2 and 4 for this side. So we number it from the lowest possible side and we go end to end. Now to find the substituents. This is a methyl group attached to the second position and another methyl group attached to the fourth position. So we have 2-methyl and 4-methyl. Going on to the next example. So we have this as our parent chain, and if you notice, this is not a methyl. So there are 2 carbon atoms. So the group's prefix is eth, and so it is an alkyl. It is ethyl. So to find the number where the ethyl is arranged, we can go from either directions. Makes no difference. This carbon atom would still end up getting the number 3. And here we have 3-ethyl. For the last one, we have 2 kinds of substituents attached. One is a methyl group and second is an ethyl group. So if we were to number it from this end, it would have been 1, 2, 3, 4, 5, and here it is 1, 2, 3, 4, 5. So both ways you get 3 and 5 for both the substituents. But the rule says that if we get equivalent substituents, what we do is we go alphabetically. So ethyl starts with E, while methyl starts with M, and E comes before M. So the number which has the lowest value goes to the first one which comes in the alphabetical order. In this case, it is ethyl. So we would number from this end, and you see this is an heptane chain, and we have two substituents. One is ethyl, which is 3-ethyl, and the second one is 5-methyl. Moving on to the fourth step. So till now we have understood how to name the parent chain, how to number the parent chain, and how to find the names of the substituents involved. Now, if we have same substituents overall, then it becomes quite redundant to write 2-methyl, 3-methyl, and so on. So in this step, if you have more than one substituent, then we will add a counting prefix to it so that the redundancies are cut down. So for 2 of the same substituents, we use di, 3 is tri, 4 tetra, and so on. So now let's write the substituent names and the related numbers corresponding to that for these ones. So in the first example, we only had one substituent, so that makes no difference, it still is 2-methyl. But for the second example, we had 3 substituents. So all of these are methyl, so it would become trimethyl, and to write the numbers before them. So it is 2, 4, 4 trimethyl. Now if you notice, if you have tri as the counting prefix, there should be 3 numbers here. You cannot ignore 1, 4 because both the methyl groups are attached to the same carbon. You cannot do that. You have to account for all the substituents that you have written for with their numbers. So it is 2, 4, 4 trimethyl. If you notice here, the numbers are separated by commas, and the number and the word is separated by a hyphen. In this example again, so we have the 6-membered chain as the carbon chain, and then we have 2 substituents here. So we will use the counting prefix di. So it is 2, 4 dimethyl. This has no problems at all. It only has one substituent attached to it. So this is 3-ethyl. And for the last one, we have 2 substituents. So we cannot add counting prefixes to it because they are 2 different substituents. So we go 3-ethyl, 5-methyl. And if you notice here, I have written the alphabetical one first, and that is exactly what you have to do. And the numbers and the letters are separated by hyphens. Moving on to the last step, where we finally write the name of the compound. So we will write all the substituents before, and then you will write your parent's name, and that's all there is. So we know that this is 2-methyl, and then it's a pentane. So we simply write pentane afterwards. For the second one, it is 2,4,4 trimethyl pentane. Now for the third one, we saw that the parent is a hexane chain. So now it becomes 2, 4 dimethyl hexane. This one is 3-ethyl pentane because the parent is a pent chain. And the last one, we have a heptane chain. So this becomes 3-ethyl 5-methyl heptane. So that is all about naming these alkanes. So some of the common substituents that you need to be aware of are the methyl, ethyl, propyl, butyl, and there is one thing called isopropyl. If you look at it, you have 3 carbon atoms, so it is definitely propyl. but the attachment is from the second one. So this is called isopropyl. With regard to the first one, you see that the first one which is left out is the one which has to connect to. And some of the common non-alkyl group that you have to know about is FClBrI, and their names would be fluoro, chloro, bromo, and iodo. So that's it for today. Happy learning!